Today we're doing lesson 6.6. We're doing geometric sequences. Now we did arithmetic sequences before Christmas, so now we're going to look at geometric sequences. You're going to see a lot of similarities, but there are a few key differences that you're going to make sure that you're going to highlight. So keep that highlighter close so when I tell you to highlight something, you can highlight it. The essential question is, how can you use a geometric sequence to describe a pattern? Well, what is a geometric sequence? The ratio, or what we will refer to as the common ratio, between each pair of consecutive terms is the same. So just like in an arithmetic sequence where we had to either add or subtract the same number all the way across the list, it's the same with a geometric sequence, except each term is found by multiplying. And this is going to be important. You don't have to think about it. Once you find the common ratio, you're multiplying it all the way across the list. Now, as a quick review, the arithmetic sequence has a common difference. Okay, geometric has a common ratio. Arithmetic has a common difference. How did we find the common difference? We found it by subtracting the second term from the first term. Okay, that's going to be important when we go here to example number 1. We're supposed to decide whether the sequence is arithmetic, geometric, or neither, and then we're supposed to explain. But just like last time, as long as you explain using your work, then I won't look for an actual sentence explaining your reasoning. All right, if you show me your work, that will be good enough. Now, take your highlighter and highlight how you find the common ratio. It is the second term divided by the first term. So the common difference is the second term minus the first term. The common ratio is the second term divided by the first term. So I want you to highlight that little formula because that's very important to what we're going to do today. Now, we're supposed to figure out if these are arithmetic, geometric, or neither. So we're going to start out on letter A. Let's just test arithmetic right off the bat. Okay? We are supposed to take the second term, which is 1, and we're supposed to do what from the first term? Subtract it by the first term. So 1 minus 5 is equal to negative 4. Now let's test it. Remember, it has to work all the way across. We already know it's going to work between the 5 and the 1, but we're going to write it down anyways. Let's see if it works from 1 to negative 3. What is 1 minus 4? Negative 3. So we keep going. Negative 3 minus 4 is what? Is that the next number in the list?
Of course.
All right. Then subtracting 4 works all the way across. So what kind of a sequence is this? Arithmetic. Remember, if we are able to add or subtract a number all the way across, we know it's arithmetic. Not to mention, we found a common difference. All right, very good. Now, letter B. Let's start with, again, arithmetic. So we're going to take 128, which is the second term, and we're going to subtract it from the first term, which is 1024. And what does that give us? It gives us negative 896. Now, again, we already know it's going to work between the first two, but we're still going to write it down. Let's test it from 128. What is 128 minus 896? Is there any possible way that gives me a positive 16? No. So I'm going to go over here and I'm going to cross it out. I'm leaving it, but I'm crossing it out because I know it's not arithmetic. Now we're going to test for geometric. So I'm supposed to take 128 and do what with it this time? Divide by the 1024. So it's the same two numbers. I'm just dividing this time. So what is 128 divided by 1024? Put it in your calculator, you get 1/8. Now, what are we supposed to do with the 1/8? Okay, somebody besides Alonzo who's answered every single one of my questions, which is awesome, but I got to make sure everybody else gets it. All right, what do I do with the common ratio every single time?
Multiply.
I go multiply it by all of those numbers. All right, so I know it's going to work from 1024 to 128, but I'm still going to write it down. All right, what about 128 times 1/8? What does that give me? That gives me 16. All right, what about 16? Trevin, what's 16 times 1/8? It equals 2. So, since multiplying by 1/8 worked all the way across, what type of sequence is this? Geometric. Very good. Again, as long as you've shown me your work, I am going to take that as your explanation. All right, letter C. Let's start with arithmetic. So we're doing what minus what?
6.
6 minus 2, which equals 4. All right, we know 2 plus 4 is going to give us 6, but what's 6 plus 4?
10.
10, all right, but we keep going. Remember, it's got to work all the way across. What is 10 plus 4? 14, and what answer is up here in our list? 16. All right, so we know it's not arithmetic. It's not arithmetic, so now we got to try geometric. So what am I going to do? I'm going to do 6 divided by 2, which equals 3. All right, and what are we doing, Deja, with the 3 all the way across the list? We're going to multiply. All right, so we know 2 times 3 is going to give us 6. What is 6 times 3? 18, but the next number is supposed to be a 10, so it's not geometric either, which makes this neither. Very good. Again, as long as you've shown me your work, I'm going to take that as your explanation. Let's go to example number 2. Now, we're supposed to write the next 3 numbers or the next 3 terms of the geometric sequence. So we know it's geometric because it's told us. So really, we just need to find the what? A common... Nah, it's not a difference. It's a common ratio. All right, very good. So Yasmin, for letter A, how am I going to find the common ratio? 3 divided by 1, which gives me 3. Now, I'm supposed to do what with that 3, Yasmin? Multiply it. And we know they've already done that. 1 times 3 is 3. 3 times 3 is 9. 9 times 3 is 27. So we're just going to do times 3 there at the end on the 27. So what is 27 times 3? 81. Very good. Now we're supposed to take 81 and do what? Multiply by 3. And what do we get? 243. And what are we supposed to do with 243? Multiply it by 3 and we get 729. So there are the next 3 numbers in the geometric sequence. Awesome. All right, letter B. Amari, how are we going to find the common ratio for letter B? I'm going to take negative 40 and I'm going to divide it by 80. And what does that give me? That gives me negative 1/2. So what are we supposed to do, Timothy, with the negative 1/2? Multiply it. So right here at the end, we've got a negative 10. We're going to multiply that by negative 1/2. And what does that give us? That gives us 5.
Yeah.
All right, we're multiplying 5 by negative 1/2. And what does that give us? We're going to leave it as an improper fraction. Give me a fraction. Give me an improper fraction. Negative 5 over 2. And when we multiply that by a negative 1/2, we get what? Positive 5 over 4. Now, let me teach you something to help you. Okay, those of you who really want to make sure that you're doing this right. If your numbers are positive, negative, if every other number is negative, then what does that tell us about our common ratio?
Negative.
It must be negative. Okay, it's the only thing that makes sense because a positive times a negative is a negative, but then a negative times a negative is a positive. Okay, so if you're looking at a geometric sequence and every other number is negative, yet your common ratio is positive, you have done something wrong. Okay, so let me say that one more time. If you're looking at a geometric sequence and every other number is negative, then make sure your common ratio is negative. Now, in example number 3, we're going to actually just do this real quick. We're not actually going to take the time to graph this, but I do want to remind you how to do. You've done this before, but I want to remind you in case you do run into a graphing problem. Remember, the position of the number is the x-coordinate. The number itself is the y-coordinate. So, what number sits in the first position? 32. So the ordered pair would be 132. Now, write these ordered pairs down. Like I said, we're not going to take the time to graph it, but we're going to write down the ordered pairs. What number sits in the second position? 16. So 216. What number sits in the third position?
3, 8.
8. So 3, 8 would be the ordered pair. What number sits in the fourth position?
4,
4. So 4, 4. And what number sits in the fifth position?
5,
2. So the ordered pair would be 5, 2. Now, when we go to the geometric sequence, the equation of a geometric sequence, again, this should look very familiar from arithmetic, but there is a new formula that you have to memorize. So take that highlighter and highlight the formula that you need to memorize. It's a sub n equals a sub 1 times r raised to the n minus 1. Now, notice I said times. If there is no sign between the a sub 1 and the r, What operation does that let me know?
Multiplication.
It's multiplication, all right? So be very careful, because when we start plugging things in, we're going to plug things in parentheses so that we can show that multiplication. Now, a sub n, this should look familiar, is the term you are looking for, all right? They could fill that in with a 2, a 20. What number are they asking us to find? Which position? So that's a sub n. A sub 1 is the value of the first term, all right? What's the first term in the list? That's your a sub 1. N is, again, the position number. We already talked about that. And then R is the common ratio. And one more time, the little formula, second term divided by first term. Now, in example number 4, it says write an equation for the nth term of the geometric sequence, then find a sub 7. So again, we have done this before, but the formula is new, so we got to be careful. To write the equation, here's the next place you're going to highlight. We have to plug in a sub 1 and R. So let me ask you this. This tripped up some of my earlier classes. If I'm supposed to plug in a sub 1 and R, what do I have to find for these problems? One more time. If I have to plug in a sub 1 and R, what do we have to find? Very good. So looking at letter A, really quickly, I should be able to identify my a sub 1. What is my a sub 1? 1. The first number in the list is a 1, so it is my a sub 1. Now, how am I going to, Anthony, find the R? Because I got to find the R as well. Common ratio. How do I find it? I'm going to divide negative 5 by 1, and what does that equal? Negative 5. Awesome. So I have found a sub 1 and R. Now I have to plug it in. So let's write down the formula. Again, if we write down formulas, it helps us memorize them. A sub n equals a sub 1 times R raised to the n minus 1. Now literally all I have to do is plug in a sub 1 and R. So a sub n equals 1. I'm plugging the ratio in parentheses. This allows me to remember I'm multiplying. So I plug in negative 5 and I raise it to the n minus 1. This is as far as I can go. Why? Why can I not go ahead and do the 1 times the negative 5 and then raise it to the n minus 1? Okay? Because, but that's not why. Here's why. Remember the order of operations? Please excuse my dear Aunt Sally. Am I allowed to multiply before I do exponents? No. So this is as far as I can go. This is it. That is the equation. Now, I've got the equation. It wants me to find which term? 7. So I'm going to take a sub 7 equals 1 times negative 5. And what am I putting in place of that n?
7.
7, because that's the position they want me to find. So a sub 7 equals 1 times negative 5 times, what's 7 minus 1? 6. Now, it's very important that we put this in the calculator correctly. Again, remember, I must do the exponent first. Also, 5 is what kind of 5? Negative. So when I plug it into the calculator, it must go inside of parentheses. If not, you will get the wrong answer. So we plug in negative 5, we raise it to the 6th power, and then we can multiply it by the 1. But what do we get as our 7th term? 15,625. Now again, notice it's positive because that negative 5 was raised to the 6th power. So be careful when you plug that into your calculator. For letter B, we got to do the same thing. We've got to identify a sub 1, which is what in this problem?
432.
Good, 432. And then, of course, we have to find the common ratio. So to find the common ratio, I'm going to take 72 divided by 432. And what does that give me? 1/6. So my common ratio is 1/6. Let's write down the formula. A sub n equals a sub 1 times r raised to the n minus 1. So what am I plugging in place of a sub 1? 432. In parentheses, what is my r? 1/6. And I raise it to the n minus 1. Again, this is as far as I can go. Please, please, please do not do 432 times 1/6 and raise it to the n minus 1. It's wrong every single time because of the order of operations. All right, now they want us again to find the 7th term. So a sub 7 equals 432 times 1/6 raised to the 7 minus 1. A sub 7 equals 432 times 1/6 raised to the 6th. What has to go into the calculator first?
432.
Nope.
1.6.
We have to do the exponent first. So we have to do the 1/6, raise it to the 6th, then we can multiply by the 432. And what do we get as our final answer for a sub 7?
1 over 108.
1 over 108. And that is lesson 6.6.